Hello and welcome to this repair tutorial, and today we're going to look at a Marantz, and the model number is PM7200, and this is the KI signature version. In terms of general specifications, power output in class AB mode is 95 watts RMS into 2 times 8 ohm speakers. If you select from the front class A mode, then it's 25 watts RMS, again into 2 times 8 ohm speakers. From the front, you can have dual sets of speakers connected, and you can select between System 1 and System 2, or for private listening via the headphone jack, then you can just disable both. You can override the tone controls via the direct mode, and frequency response is 10 Hz to 50 kHz. You can connect directly a moving magnet turntable. Input sensitivity is 2.5 mV, and then for all of your other line inputs, it's 150 mV. Dimensions 440 by 159 by 374.5 millimeters for width, height and depth, and weight is 12.3 kilograms. The amplifier also would normally be supplied with a full-featured remote control to select not only the motorized volume control, but also to select any of the inputs. Now, the owner of this amplifier contacted me, and the information that I received was that this amplifier had been bought second-hand. So really he didn't have any sort of background information, but it was actually sold as being faulty. So when I sort of put it on the bench just to do the initial sort of checkout, the amplifier powered up, but you had some of the issues which are common where, for example, you have intermittent loss of sound. But on the left channel, you had intermittent audio, and it wasn't really linked to, for example, dry solder joints, but I'll get into that as we go through. What you see in here is the underneath of the amplifier, and the reason why I'm showing you this is there is a service plate which gives access directly to the amplifier main board underneath. And often when repair work is carried out, what you'll find is that the metal tabs have been snipped and then self-tapping screws put back in place to secure the plate. Thankfully here, it didn't appear that this amplifier had ever been worked on. And from an engineer's perspective, that's a better place to be. And then here when we look from the back of the amplifier, you can see the usual links which are on the top left hand side, which is where you will connect the preamplifier to the power output stage of the amp. And then if the customer or the owner wish, they could disconnect that and then connect, for example, a different preamp, or they may well drive the preamplifier output from here into another power amplifier. What's very important is that you have a common ground connection. So when you see these screws which go through the speaker terminals, there are ground connections internally. You just need to make sure that once you've done the repair work on the amplifier or you're in test phase, that this back panel is secured in place. Now, the first part of the work to undertake is really to take care of all of the age-related issues. So here what I'm showing you is just the back of the amplifier now with the back panel removed. And you can see on the left-hand side, this is where we have all of the different RCA sockets. Center is the main amp board. You can see the toroidal transformer. And then on the right-hand side, you see the power supply, and then front is where you have your tone volume control, and also where the microprocessor is located on the front main board. So it's a straightforward task really, just to go in a systematic approach and just re-solder all of the solder connections. And for people who follow these tutorials on a regular basis, I've repaired a lot of these amplifiers over the time, and you have to do all of this work first off. The reason for that is you've got to kind of get the amplifier into a known good position before you go and look then to do further fault finding. Also for this amplifier as well, all of the electrolytic capacitors were also checked with a ESR meter, and all the capacitors were found to be within manufacturing tolerance, and there was nothing in there which was high ESR or low in value. So I suspect maybe this amplifier hadn't been used extensively. And then here, this is what I would term as the piggyback board. This is where it plugs into the main input board. And you can also make out as well all the red relays. So these are the signal relays, and there's 13 of them in total. And it's just a straightforward task. As I've said, just resolder all of the connections. There were quite a number of these where they'd broken away from the circuit board. And then here what I've done is I've removed the main amplifier circuit board, and I've just put it onto the bench and then put the rest of the chassis to one side. And that enables you then to carry out really detailed work. So I've put a number of circles just to highlight additional information here, and also pointing an arrow at a board. And then where you see the green circle, underneath those bronze or copper canisters, is where you have the input stage then for the amplifier. You'll also find as well that there is 2 presets, one for each channel, located nearby, and this is where you will do the adjustment then to correct any DC offset. The blue circles are the emitter resistors, and that's important when we come to do the alignment of the amplifier, because that is where you will measure the current flow via those emitter resistors. And then at the rear, I've put a red circle around the speaker protection relays. These will also be replaced, which is standard, and you find often that the customer will report that they have not only intermittent loss of sound, but maybe distortion because the contacts inside have become resistive and oxidized, or sometimes at low level volume it sort of breaks through until you increase the volume and more current flows through the resistive contacts. And then the board, which is mounted vertically, this is the speaker protection board, and again we'll address that in terms of dry joints and what work we need to do. So I've been through this multiple times through different tutorials, and this board is literally a complete resolder job. There's nothing on here where you look and you say, oh, actually that doesn't need to be resoldered. I always emphasize the point, just take your time, make sure that you're checking your work. You want to avoid any solder bridges, but check every single connection. And then at the same time as well, replace the speaker protection relays. Now, because of the age of the amplifier, what I also did was to remove the fixing screws for the driver transistors and output transistors as they bolt through to the heat sinks. And what was interesting to find here is that you can see during manufacture, they didn't do a very good alignment with regard to the mica washers. So you can see here that a screw has gone through part of the mica washer and not through the actual mounting or fixing hole. And there were a number of these mica washers which needed to be replaced. You can also see as well, there's not a lot of heatsink compound. So we replaced all of that heat transfer compound just to make sure that the power output transistors are dissipating the heat and they're not running excessively hot. And then this is the speaker protection board. Now, what I did find with this board is at some point in time, it looked to have had some work on it. So although the surface plate hadn't been removed, someone had definitely had a look at this. And again, we did the ESR check and the capacitors were good. But it was just a case, as you see here, just to resolder all of those bad solder joints. Now, during initial inspection, what I found was that the toroidal transformer was loose. It actually was moving around on its fixing plate. And you can see here, because this is the KI signature, it doesn't have the EI transformer. So it's an improved transformer, lower noise. And then here what I've done is I've just removed it from its mounting, because you need to put a slotted screwdriver into the fixing bolt and then just use a spanner to lock that nut back in place. And you just make sure that the transformer is held correctly. As with many things, you don't want to over tighten, so it should be firm, just to provide no movement, but please don't over crank it where you could maybe damage some of the transformer windings. And then on this photograph, what I'm looking at now is the main power supply circuit board. So you can see the small EI transformer, and this is the startup transformer. You can see the power relay and then the protection fuses. And then the two large canisters are the main electrolytic smoothing capacitors and the associated bridge rectifier. To remove the board is straightforward, so there's just a series of fixing screws. But what I would advise you to do is just use a capacitor discharging tool just to make sure that you discharge the current or the energy which is stored within those large electrolytic capacitors. That means that you can then move the board around quite freely, and when you're trying to relocate it back into the chassis, even if you inadvertently did touch the main metal parts of the chassis and the capacitor shorted out, you're not going to have a high discharge of energy which could cause damage to the circuit board and also to the chassis. Now here what you will find is multiple dry joints, as I keep saying, and you must go meticulously and resolder all of them. Here you have the relay which is used in the Class A mode. So this is where the relay will energize when you push the button from the front, and what it will do is it will select a lower voltage winding in the Class A mode. The higher voltage is when the relay is de-energized and you're in Class AB mode. What you find, as with any relay contacts, they just become oxidized. Don't try and remove the top cover of the relay while it's mounted on the board, just desolder it, and then you can unclip it, get into there with a fiberglass pencil and some De-Oxit, clean up the contacts, and then reassemble it. And then here we're looking from the rear, so what you're looking at now is the tone board, and then on the left hand side is where you have the volume control, and then at the front that's where you have the main microprocessor board. And then what you always find, as is common with all of these amplifiers, gain dry solder joints. So there's lots of dry solder joints on the volume control board, and there's lots of dry joints on the tone control board. I've put some circles here. The ones on the right hand side and on the left hand side nearest to you, those are voltage regulators, and there's always dry joints on there, and also the multi-pin switch. You'll also find on the bass, treble and balance control potentiometers dry joints. And what I found here was that the tone defeat switch had a lot of internal oxidization. So even using De-Oxit D5, it wouldn't clear it. So I had to disassemble the switch, and that's what you can see here. So you can see just towards the left-hand side, that heavy layer of oxidization on the contact. So just took a fiberglass pencil and then just rub it up and down, clean that away, and then apply the De-Oxit D5. And you can all see the slider controls, those were also cleaned. And then once the switch was then reassembled, I didn't have the issue associated with the resistive contacts and the oxidization. And then here, this circuit board is where the headphone socket and the System 1 and System 2 speaker selection switches are found. You always find dry solder joints on the headphone socket and also on those selection switches. But all of the other user controls and switches were cleaned with De-Oxit D5 and they were perfect. There was no issues. And then this circuit board here is your input selection circuit. So what you have is an encoder, and when you rotate it, then the microprocessor will read it directly and then select the appropriate input via the signal relays and illuminate the required LED on the front fascia. It plugs in and then locked in position by a locking nut. Always dried solder joints, so just take the time to resolder all of those. And then here, what we're looking at is the microprocessor. And because this amplifier is a very early version, it's using a 4-bit micro. Now, what I found was, when you sort of turn the circuit board over, and this is what you can see on this photograph, one side of the micro was really not even soldered in. None of the pins of that side of the IC were pushed through, so I had to desolder all that solder away, then push the IC back into position and then resolder. So this is a manufacturing issue, and it could have failed at any point in time. And then here what I'm showing you is just a technical bulletin extract dating back from 2007. And what it's giving you is some background information for the microprocessor. And then here what you can see is that it is a standard 4-bit micro, but it's linked directly to the serial number. So this amplifier is an early version, so it's using the 47C200BN micro. But at a later date, what Marantz did was they adopted then an 8-bit micro, and you can see here on the service bulletin extract, it categorically states that on the early versions, you cannot use the newer 8-bit micro. You have to go and source, if you can, a 4-bit micro, which is not easy. Now, I had the microprocessor board out, and then what I found during the initial test phase is that if I press the Class A mode, you couldn't see any illumination on the front. And then when I took the board out, and I've circled it here with a blue circle, the LED was bent over. So again, was this done during manufacture, or had this board come out at some point in time? And then when we look at this intermittent issue with regard to loss of the left channel, what I'm showing here is quite a busy extract from the service manual. So what this is showing you, it is showing you the KI signature input stroke output stages. So these are the 13 individual signal relays, which in turn are switched via associated transistors from the microprocessor. Now, if I go a little bit more detail and we zoom in, you can see all of the different switching contacts. Now, the relay type, it was manufactured by NEC, and it's an MR62-24 USR, but they are now obsolete. Now, what I did is just took some time then to try and source a modern day equivalent, and what I found was that these TE connectivity with a part number of C93431 matched exactly the same specifications, including the resistance of 1050 ohms for the coil. So I did actually locate finally some of the original relays, but for future reference, if you're repairing one of these and you need to change any of these relays, then you can source the TE connectivity ones. Now, what you found here was that you can take the board out of the main chassis, and what I found was if I sort of just tapped a number of the relays, the audio would then come through and it was fine. But as soon as you tap the relay again, then it would disappear. And you found this if you were selecting between different inputs. Now, initially, I kind of felt maybe there was some kind of crack on the circuit board or something like that. And then what I decided to do was just to use the audio signal tracer, and I could trace it through to different relays. But if I bridged the switching contacts over, then it fixed the fault. So it wasn't a crack on the board. There was something going on with these relays, clearly age-related, and the switching contacts. So all I can do in that case is, rather than just sit down and say, okay, I'll track it down to maybe 2 or 3 relays, just to make sure that when the owner of the amplifier receives it back, that you have the reliability, I simply replaced all of these relays. And you can see here that during testing, because you can remove the amp board from the main chassis, it makes it very easy then just to track it in terms of audio. The multi-pin cable is connected directly to the main board at the front where the microprocessor is located. Once all of those relays were replaced, the intermittent left channel audio loss had been fixed. And then the final stage really of getting this amplifier back up and running, back to its former glory, is just to do the alignment. So here we have 3 adjustments which we need to make. You'll leave the amplifier running probably for about 20 minutes to warm through. And then you don't want to have any inputs connected, no speakers either. And then from the front, you set your tone controls, so bass, treble, balance controls to midpoint, and then your volume control to minimum. And then what I'm doing, and I'll show this in a series of photographs, I connect my multimeter to the rear speaker terminals for the respective channel. Just make sure that you are selecting system 1 or system 2, depending on which terminals you're going to use to do the measurement. And then what I'm looking to measure there is as close to 0 millivolts with a tolerance of plus or minus 10 millivolts. If it's out, then you need to make the adjustment to bring it back in. And then once that is done, you need to connect across the emitter resistor for the respective channel. And then in AB mode, you're looking then to adjust the bias trimmer until you read 18 millivolts, again with a tolerance of plus or minus 3 millivolts. And then finally, when you select Class A mode, you will see that the bias value read on your multimeter will increase significantly. And again, you will make the adjustment so you are reading 90 millivolts, but with a tolerance of plus or minus 5 millivolts. So here what I've done is I've just put a series of circles around these different trimmers. So the ones which are nearest and have the red circle around, these are the DC offset trimmers. And remember that these are single turn presets, not multi-turn. And then if you find that they're a little bit dirty, just depower the amplifier, spray them with De-Oxit D5, rotate them backwards and forwards, get them back to their roughly original position. And then what you should find is that it's quite straightforward to make the adjustment. And then the trimmers where you see the yellow circle, these are for the bias for the Class A mode and also the Class AB mode. And then on this photograph, you can see here that we have a DC offset of 1.23 millivolts after adjustment. And then here I've just brought it down a little bit lower, so it's now 0.05 millivolts. And then here on this photograph, what you can see is that it's a little bit low for the AB, so it's 16.35 millivolts. So I made the adjustment until it was approximately 18 millivolts. And I like this photograph. You can see the toroidal transformer. All of the circuit boards have been cleaned up. The amplifier fully aligned and adjusted. So here with the top view, what you'd find with the KI series is this transformer is extremely quiet. You don't really hear any noise. And even when I was doing the adjustment for the Class A mode, and it was a little bit high, it's sort of about 180 millivolts, where it had drifted to over time, you couldn't hear the transformer labouring at all. And then here what we show is just some of the removed failed parts. So these are 2 of the micro washers, which unfortunately had holes where they shouldn't have been. And then you can also see the 24 volt DC coil relays. And I'll put the part number in the description for the video as well. And then, as with all of these repair tutorials, the final part is really just to put the amplifier onto an extensive test. And because a lot of work had been done on all of the different circuit boards, I ran the amplifier probably for about 4 hours and then also frequently restarted the amplifier just to make sure everything was good and there was no issues. So that sort of brings us to the end of this repair tutorial. So as always, I really appreciate you stopping by. And if you need any guidance, help or support, by all means email audioamplifierservicing@aol.com. and I'll be more than happy to provide any support that you require. So, until the next time, I wish you all the very best. Cheers and bye-bye.